Okay, so today we're going to add a new function to the stand language. This function's already been implemented in stand math. We just have to add the approved signature so that the stand compiler can recognize it. So we'll take this integrate 1D example here, and it's not working right now. And there's a little model, and actually there's a bug associated with it, which is that it needs an optional tolerance. So here's an example model, and we need both of these forms to work. So I'm going to copy this example model and add it to a test file first. So that'll go in tests, integration, good, and now I guess function signatures, math functions. Where's this in higher order? I'm going to grep and see where the other higher order functions live, like integrate, BE, and regular grep. It lives in lots of places. Good. 6 dot expected. Oh yeah, that's fine. ODE good dot stand. Yeah. I guess we could just make something like that. Well, let's just put it in here because it's kind of just another math function, right? We'll call it stand. Close this window. I'm going to try to paste. Nope. Bad at Linux. Okay. And I'm going to go ahead and add the other signature that he says should also work, which is this one. So these should both work. This line doesn't seem particularly necessary, but maybe that keeps it from complaining. Alright, now let's try to run this. Good. Functions. What's this? Function signatures. Functions. Okay. Right. So it is correctly running our test, and it is returning that same error that we saw from the new compiler on the forum here, and declared integrate 1D. Okay, cool. So now we'll go to the stand math. What's it called? Stand math signatures file, and we'll look at integrate ODE because it's going to be kind of like that. Because this integrate 1D is also a higher order function. So I'm just going to copy that, and actually this should go beforehand alphabetically. I'll just add that here, call it integrate 1D, and let's look at the type signatures. So it should be returning a real. Is that always? Let's look at the. Yeah, always returns a real, takes in a real, array of reals, array of ints. Okay. Oh, this is the integrand function. Sure, when you text in the integrand function. Okay. So this is our integrand equivalent here. So it needs to be this one here. That's real, array of reals, another array of reals, and that was right here. And then an array of ints. Cool. Returns real. And the formatter will fix some of this stuff. And the actual function is here and here, and it returns vector, which is different from that. Interesting. And it takes the function as the first arg, which is weird that we mark it as auto-diffable, but let's ignore that. The second arg is a real, another real, an array of reals, and an int array here, so we don't need this one. So it's real A, real B, real brackets data, real brackets XR. Oh, and those are data only, and these are data only, and int brackets. Okay, cool. And then let's add the other signature for the one with the relative tolerance at the end. So that just means putting these here. Is it auto-differable? It doesn't say. Oh, it says data only. Okay, cool. Cool. Now it's bad. What do we do? Oh, I have added the wrong place. That's why the indentation was weird. Cool. And now let's see what happens to our test. Well, we got rid of that one problem. That's kind of fun. Yeah, maybe this is not true. I'm going to write this. This is the whole thing. Let's see what happens. Let's just read and double check that this is not supposed to return a real sometimes. But we can also go look at stanc3. Try to find integrate. It's a lot of places. Let's look for like files that are stand files. So those are all bad. Are there good ones? No good ones. That's like source test. Alright, there's a good one. And it does return reals. Okay. Interesting. Well, there's a mistake too. Well, let's. I guess the spec is less updated than the code. Code is probably more updated. So let's just change that. All right. Oh, I forgot to make a branch. I'm going to go ahead and show you how to make a pull request too. If you already know how to do that, you can go ahead and skip the rest of this. Make sure I'm going to run. Oh, I'm going to run the formatter first, which is important. So we have a cool tool that auto formats everything nicely, and then Dune has a nice facility to promote it. So first it shows you what the difference would be, and then you can write Dune promote to actually go ahead and do it. Speaking of which, I need to do that for the test as well. So we ran the test, and it showed me the difference, and then I did not promote it. So let's do that. Now we have some test changes, and I need to add this file too. Let's see. What was this issue? One. Also fixes stand of. How do you do this? Stand of. Delicious shop. Oh, it was right here. 2786. So when we commit, we have a hook that runs some of the tests in formatter. Now I can push this up to origin and go back over to Stan. And look it over. So I should say Matthias made this system for actually including these higher order functions in our type system. And that has been really a big win because this is the code we have to change, obviously to do the thing that I just did. To look at the old compiler, just find that change. It's something like 40 files changed. Integrate one. Okay, whatever. Yeah, it's 43 files, 600 lines. This is one file of actual, I guess that's not fair. It's 3 files total, 65 lines total, but basically just one file with 25 lines. Oh yeah, some of this is manual too, so it's like super not fair. But a lot of these files are actually compiler files. Yeah, all of these files. That's quite a lot of them. Maybe half or something. Yep. Okay. Well, that's it. Thanks for watching. Bye.